Hello. We want to implement a stack ADT. And how are we going to implement a stack? We use linked list. Here is an example of a stack being represented by a linked list. Now, the top of the stack is going to be our head position of the linked list. Okay, that's the view we are going to take. Now, so what is the top of the stack now? The top of the stack contains the number 35. And I want to implement the stack functions in this linked list. And what is so let's look at one. The first stack function is push, and I want to, let's say, push 75. What is it I need to do? I need to create a new node, and which should appear as the head of this linked list. And how do I do that? Something we already saw, how to add a new element to the head of a linked list. We saw this thing, right? And how do I do that? I'm going to create a new node. I create a new node and make the head point to that node. It's clear, it's easy. How much time does it take? It just takes, you saw one, you created one extra node, that's it. You didn't traverse the entire linked list, so you just created a one new node. So this is a good implementation of a push function. Right, and now next function. What's the next function we are interested in? Pop. Now, if I pop, which element should be popped? So I have to pop out 75. I have to remove 75 from this linked list. Do we know that? We know how to do this. Again, I rub off this node. I rub off that node and make it point to the second node in the list. So pop is also easy to implement. We saw just one node. We didn't have to traverse the entire linked list. So it's also very easy to implement. A singly linked list can now implement a singly linked list can implement the stack ADT. Thank you.